Okay, AP Calculus, back with another AP Calculus instructional video with Mr. Berto here. So you guys are receiving this video, I believe, on Wednesday. Remember yesterday, Tuesday, the differential equations take-home test was given out to you. It's not due until Monday, but I know that, starting tonight at sundown is Passover, Thursday and Friday, holy days for many people. You got Easter on Sunday. So I figured, hand it out, let you guys work on it. Hand it out, you guys print it or write, answers on a separate sheet of paper. Get that to me sometime, by midnight on Monday, okay? So you have time as far as when you could do it. You could do it Tuesday when it was given out. That would be yesterday. Or you could actually worry about it, like I said before, on Monday. Where are all my pieces of paper that I need? Here they are. Anyway, so as far as your AP exam is concerned, okay, some information was given out. We're starting AP review today, okay? I'm going to do AP review the old school way that I always had it done. Because look, it's not just about the AP in here. I know you're like, oh, it's a shorter AP, whatever. I want you guys to be prepared for the future. So even the topics that they took off the AP, we'll review them a little bit. We won't go too crazy in them. But we're also going to review multiple choice and stuff like that. As far as writing out what your AP exam is going to look like, it's going to be a lot different than previous years. Okay. Your AP exam will consist of 2 questions. All right, it used to be that there was 45 multiple choice questions and 6 free response questions. You get 2 questions that are free response, which really means part 2, show your work. I believe they're supposed to be non-calculator questions, okay? But you will have the calculator anyway. They can't stop you from using it. So I'm not sure how much the calculator is actually going to help. I think it's just going to be problems where the calculations are easy. But once again, we'll talk about that more when we need to. Nobody knows exactly what the questions are going to be, but they said they would model previous free response questions given before on the AP exam. Those you normally want to average 15 minutes apiece. One question will be 25 minutes that you'll have. And the second question will be 15 minutes. So I'm not sure how they could take a normal question, which usually takes 15 minutes, and make it into 25 minutes. Usually there's only part A, B, C, and D. Not all of them have 4 parts AP questions. I've seen anywhere from 2 parts to 4 parts. Maybe this guy has 6 parts or 8 parts. I don't know, okay? But I believe both of them, if my reading is correct, should be done without a calculator. So don't need calculator, all right? They can't stop you from having it next to you, okay? And the questions will be timed when you take your AP online. I think it's going to be online anyway. The AP exam, let's see, they changed that date to, I want to say it's May 12th. I don't know if that's right, okay? I just don't have the information in front of me, and I'd check on my phone, but I'm using it to record this video. So it's May 12th, I think. Not the biggest deal in the world. I don't know. We might be back in school by then. I doubt it. Okay. If we are, will you take the AP exam in school? I don't know. These things are all up in the air right now. Try not to worry about it. Okay. As far as today, let's go through a part 1. Okay. It's going to be a lot of work right here. Really, this is the lesson for Wednesday, Thursday, and Friday. I know Thursday and Friday are holy days for people, like I said. So really, whenever you get a chance, download 2008 AP exam section 1. You'll also download it with the solutions. This first part is no calculator to be done. We'll go through the problems and how to do them, okay? But you should really try them on your own first. And then if you're struggling, you look at the answers, can't figure it out, look at this instructional video. So it's kind of like a supplemental video, even though we're starting AP review right now. Also, I'm having printer issues, okay? So I'm not going to actually be able to write on these dittos because it's my only copy. So I'm actually going to have this and then write on, another paper right here, which is really going to get annoying, but it is what it is, okay? So as far as the AP exam, 2 questions for response, one 25-minute, another 15 minutes, and let's get rocking and rolling with some AP review, okay? So as far as AP review is concerned, this is actually the section 1 from 2008. Okay, so you can see it right here, 2008, section 1. Okay, we'll write down some notes as we need to, but really it's going to be tough at first to remember all the stuff that we did all year, especially with all these things that are going on. So you could always pause. Remember, First part of the review is this is totally randomized, okay? Part one, they just give you topics in random. Usually it kind of moves in order of difficulty, but not always. Then after this, we'll actually start getting into specific topics. We'll do free response questions. That'll be topic by topic review. After that, we'll do another part one. You should feel a lot more comfortable at that point. And then we'll do more and more and more, okay? So as far as number one is concerned, they just want to know what this limit is right here. Limit as x approaches infinity, okay? Remember, this is when you want to compare degrees, top and bottom. Find out if the top grows quicker than the bottom, vice versa. You can see up top, you only want to care about terms of highest degree. Okay, you can actually FOIL this whole thing out, double distribute if you want to, but the 2x times the negative x is going to give you a negative 2x squared up top. That's all you got to worry about, okay? The rest of the terms are going to be lesser degree. You could actually slice them out, so we don't care about those lesser terms right there. And downstairs, you'll generate the term of highest degree by doing x times x, which will give you x squared. And remember, if it's a limit as x approaches infinity, if the degrees are tied, we divide coefficients of the terms of highest degree. Negative 2 divided by 1 is going to give me that negative 2. That's choice B right there. Okay, remember, whenever you have do the three situations, top degree greater than the bottom degree, that means the top grows quicker than the bottom. You're approaching positive or negative infinity. That's a non-existent limit. Sometimes they want you to figure out which one. We'll deal with that when we need to. Sometimes you got bottom degree. My dryer, the clothes are done. Greater than the top degree. And that means that if the bottom grows quicker than the top in a fraction, you're getting closer to 0. And here we have the situation where the top degree equals the bottom degree. And when the degrees are tied, we divide coefficients. And that's only the limit as x approaches positive or negative infinity of a rational function, polynomial over a polynomial. No difference between approaching positive infinity and negative infinity. So a little bit of review right there. Moving on to number two. All right, number two right here, pretty classic integral, the integral of 1 over x squared with respect to x. Don't fall into the trap of being like, oh, it's ln, absolute value x squared, and x squared doesn't need an absolute value, it's always positive. Look how smart I am. No, that's when you integrate a quotient and the bottom's not being raised to a power. You can see the bottom's being raised to a power here. So I just write this as the integral of x to the negative 2 with respect to x. Really basic, simple integration. Add 1 to the exponent, divide by that number. And we get what? Negative 1 over x plus c, which they actually have written as negative x to the negative 1 plus c. So they actually didn't get rid of the negative exponent. Sometimes stuff like that is going to happen. Okay, so things to think about. So hopefully 1 and 2, you don't really feel too terrible about. Okay, moving on to number 3. Number 3 gets slightly snarky, okay? They want to know, given f of x right here, still very abstract, what's f prime of x equal to, excuse me, what's f prime of x equal to? Look, you can see product rule situation here for number 3. Has the product rule start? Everybody. Second! All right, the second function we know is x squared plus 2 quantity cubed times the derivative of the first, which is 1, plus the first, which we know is going to be x minus 1. Times the derivative of the second. Shane, to take the derivative x squared plus 3 quantity cubed. Drop the 3 down like it's hot. Rewrite the x squared plus 2. Raise it to the 1 less. Don't forget to multiply by 2x, the derivative of the inside. Okay, so be careful with that right there. If you simplify this a little bit, just get rid of those parentheses. We get what? X squared plus 2 quantity cubed. Here plus, what's my coefficient in front? 6. Put the x next to it, then the x minus 1, then the x squared plus 2 quantity squared. It's really set up nicely here. The problem is those answers aren't in multiple choice because these two terms, and there are only two terms here, they have something in common. They both have x squared plus 2. This guy's got him quantity to the third. This guy has him quantity to the second. We're going to factor out the lower exponent as always. We factored out a binomial before. We did this problem last year. He still has an x squared plus 2 quantity to the first left. Plus, that's this plus sign right here. The 6x is still there, which you want to grow up to be. The x minus 1 is still there. The x squared plus 2 quantity squared, we factored him out. He's no longer there. And remember, if you do this the right way, we still got the x squared plus 2 quantity squared out here. Remember, that's the GCF. For anybody who's confused, the GCF, okay, and inside here, we could drop the parentheses, x squared plus 2, distribute the positive 6x squared, negative 6x, and now write it up nicely, x plus 2 quantity squared, 7x squared, combine some like terms, minus 6x plus 2. And I believe that answer is there. It is. It's letter choice D. Okay, so not a terrible problem. If you actually look at the solutions for these problems, you'll see a little percentage in the bottom right of each problem, which tells you the percent of people who got it right. And you realize those percentages, they can be ridiculously low. Like the amount of people who got this problem right here, if I could find my little percentage sheet, okay, I could see is equal to 39%. So 39% of the people who took the AP exam got this problem right, okay? So if you could get this problem right here, you're in that upper 61% right there, okay? This is 39% of the people who got the problem right, pardon me, okay? So look, you're doing much better if you can get a problem like this. So many people on the AP exam can't handle something like this. That should really inflate your confidence more than anything else. Taking a look at number 4 here. Number 4 rhymes with bore. Hopefully these videos aren't too much of a bore for you. Knock, knock. That was terrible. Little integration action over here. We could break up integration over addition, which is quite lovely. Okay, but you have to integrate each of these separately. If you integrate sine 2x with respect to x or cosine 2x with respect to x, that's a u substitution situation. I'd set u equal to 2x, which means we know that du over the derivative of u, which is 2, is going to be equal to dx. And it's funny because they call it u substitution. They should call it 2 substitution. This now becomes the integral of sine u plus cosine u. Take out that dx, replace it with a du over 2. So you actually don't need to break it into 2 integrals, okay? Right now you could actually pull that constant out. It's not even a 2, it's a 1/2. Bring them out, bring them out. Then do the integral of sine u plus cosine u with respect to u. And that's really 1/2 times, in a world of integrals, sine is the bad guy. Negative cosine u plus, in a world of integrals, cosine is the good guy. Plus sine u plus c. You can put the plus c in there, distribute the 1/2 to it. 1/2 times c is just another constant. So negative 1/2 cosine of, don't forget u is 2x, plus 1/2 sine of 2x plus c. Take a look, see if that answer is there. Okay, and I believe it's answer choice B. Talking about test taking techniques here. If you had no idea how to do this on the AP exam, you can see that 2 of these problems have, 2 of the answers have 1/2s in front, 3 have 2s in front right there. Usually, believe it or not, the one that has 3 is usually the answer, because when you knock things down, then you're only stuck, you're stuck with 3 answers, not 2 answers, makes it a little bit easier. But really, this is for the people who try to integrate mentally, which is great here. Just remember, if you integrate, you divide by the derivative of the inside, so we'd be dividing by 2. Don't multiply by the derivative of the inside. That's where C, D, and E are coming from, okay? So once again, just be careful. We'll talk more about test-taking techniques as we get to them. But usually on the AP exam, actually knowing how to do the problem is usually the way that we solve most of the problems, okay? They're not really as, crazy and thought out like AP stats as you might think. They're a little bit more cut and dry, not necessarily always. This one right here, number 5, don't be like, oh yeah, let's compare degrees. The highest degree on top compared with the degree on the bottom, they're equal. The degrees are tied, we divide coefficients, 5/3, there's the answer. No, that's not infinity. This is the limit as x approaches 0. You got to plug in direct substitution. Plug in that 0 top and bottom, you get 0 over 0. It's not non-existent. It's indeterminate, okay? Further investigation is needed. I'll actually factor an x squared out of the top and the bottom. So I'll get the limit as x approaches 0. Factor out an x squared. We're going to get up top, 5x squared plus 8. Downstairs, after we factor out that x squared, multiply it by the quantity 3x squared minus 16. Now these cancel out, which is luscious. Plug in your 0. 5 times 0 squared plus 8 is 8. Over 3 times 0 squared minus 16, negative 16. 8 over negative 16, negative 1/2, which is choice A. And that's the answer right there that we're looking for. So be careful with something like that in number 5. It's not comparing degrees. Okay, it's merely actually just figuring out to do direct substitution, and classic direct substitution, plugging in here. You know how many people took the AP exam in 2008, the year I fell in love, got that right? 49%. 49% of the people who took the advanced placement exam got this wrong. More than half of the kids who took the AP couldn't do this problem. If that doesn't inflate you with confidence, I don't know what will. Moving on to number 6 over here. 6 rhymes with candlesticks, and that's what Jack jumped over. Okay, number 6 over here, nasty looking split function. Remember, if x is not equal to 2, we know that means that x is greater than 2 or x is less than 2. So that's the same thing, as x not equal to 2 right there. Split function action, let f be the function defined above. Which of the following statements about f is true? Okay, we see these Roman numerals, gives everybody PTSD. Don't worry about it. Does f have a limit at x equals 2? It's the trouble spot. Is f continuous at x equals 2? Is f differentiable at x equals 2? Remember, if f has a limit as x approaches 2, there are 2 sides to every limit, okay? That means the limit as x approaches 2 from the left-hand side of f of x. We want to know, does it equal the limit as x approaches 2 from the right-hand side of f of x? And you can see, if you approach 2 from the left, you're less than 2. And if you approach 2 from the right, you're greater than 2. Okay, so I don't care if you approach 2 from the left or from the right. You're plugging into top dude either way, which means you actually only need one 2-sided limit. You don't need 2 one-sided limits. You could just take the limit as x approaches 2 of top dude, which is x squared minus 4. What was that over x minus 2? Okay, so look, you could put the x squared minus 4 over x minus 2, in each of these spots, but really you'd be doing the problem twice. And if you do this here, you see the limit is, indeterminate until you factor top and bottom. Just factor the top, right? The bottom doesn't factor. And then you could cancel, right? Cancel out the x minus 2's. And then plug in 2 plus 2 is going to be equal to 4. So the function has a limit, okay? So that means that Roman numeral 1 has to be true, okay? What'd they say? The limit has a limit as x equals 2. It does, okay? We know the limit is actually equal to 4. Now they're saying the function is continuous at x equals 2. And remember, that means the y value that the function is approaching as x approaches 2, which is 4, we just got it, has to be equal to the function evaluated at x equals 2, okay? The y value that you're approaching has to be the same thing as the y value you end up at. We know the y value approaching is 4. We just got it, right? It's the limit. But if you look at the function right here, f of 2, that's equal to 1, okay? And 4 is not equal to 1. If that was true, the cheeseburger I ate yesterday, I really could have ate 4 cheeseburgers. It'd be the same thing as eating 1 cheeseburger. That's not true, all right? So we know the function is not continuous at x equals 2. So we know that, Roman numeral 2 is no good. And then people are like, oh, got to check for differentiability. We got to take a derivative, plug into the derivative left and right. No, because if a function is not continuous, that means it's not differentiable. Okay, so if f is not continuous at x equals 2, f is not differentiable at x equals 2, which means Roman numeral 3 is also wrong. So it's really Roman numeral 1 only. Okay, that's going to be true. And we know that's A. That selection right there. So look, work smarter, not harder. Don't start taking a derivative, using quotient rule and all that stuff. Remember, if a function is not continuous, that means that it's not differentiable. Okay, so food for thought right there. Moving on, okay, to number 7. 7 rhymes with heaven, and that's a synonym of calculus. A particle, hello, particle, moves along the x-axis, horizontal line motion. Sing it with me now. If you want to take AP, it's a lifetime of devotion. Horizontal line motion. Particle moves along the x-axis with velocity given by this right here. If the particle is at position x equals 2 at t equals 2, ooh, a little initial position right there, right? X equals 2 and t equals 0. What is the position of the particle at t equals 1? So they told you the position right here at t equals 0 was 2. Now we want the position at t equals 1. People are like, we need a position function. Yeah, okay, and we have a velocity function right here. We could integrate it to get the position function. 2 ways to do this problem. You can look at my solutions. I probably did them 2 ways. Probably did the old school way where I integrated velocity. You get a plus c. Then you got to plug in t equals 0, and then you make position equal to 2 to solve for c. But really, you could use the fundamental theorem right here. And you'll see there'll be a problem like this in the, section B or part B where you're allowed to use the graphing calculator where the velocity, it's the same question basically, but the velocity function is not integratable. So you'll need to use your calculator, which means you'll need to use a definite integral. So here we'll say x of 1 equal to, remember, let's start with x of 0. And as long as you know the position at t equals 0, you want to know what the heck was the change in position? How did the position change from t equals 0 to t equals 1? And remember, if you want to know how position changed, the actual change in position, integrate the rate at which position changes, okay? If you want to know the change in an actual function, integrate the rate at which that function changes. We want the change from t equals 0 to t equals 2, okay? So remember these, to t equals 1, pardon me. Sorry about that. So remember that these values will always match up. These values will always match up as well. So really what's going on is you really have x of 0, which is 2, plus the integral from 0 to 1. And by the way, if you want the actual change in position, that's displacement. That's just the integral of velocity, not the absolute value, right? That'd be total distance traveled. So I'm just going to integrate velocity right here. That's x prime of t. That's v of t. Okay, so that means I'm actually going to do 2 plus, get a little integration going on. Integrate 3t squared. That's really t cubed, right? You took the derivative of t cubed to get 3t squared plus 3t squared. That would be the, 6t is the derivative of 3t squared, just like 3t squared is the derivative of t cubed, or just, integrate it the way you normally do. You don't have to mentally integrate it that way. Evaluate it from 0 to 1. 2 plus, plugging in the 1 first, 1 cubed plus 3 times 1 squared is 1 plus 3, which is 4. So plugging into the big bound, minus the plug in the lower bound, which is 0, so that's luscious. So you really just get 2 plus 4, which actually equal to 6, which is multiple choice selection B. If you don't like that, you could get your position function the old school way by just integrating your velocity function. It's the same amount of work as what we just did. Okay, you're going to end up with t cubed plus 3t squared, but then you have a plus c, right? And that's not enough to plug in 1 and get what position is equal to. So here, my daughter's screaming and yelling, when t equals 0, we know that position is equal to 2. So x of t is going to equal 2 when t is equal to 0. She's not getting her treat later. 2 equals c, okay? And now you can actually say, x of t is going to be equal to 3t squared plus 6t plus 2. I wish my wife would tell her to quiet down. Anyway, so now I want x of 1, which is equal to 3 times 1 squared now, plus 6 times 1 plus 2. Why do I feel like something is going wrong here? Where is this? Oh, sorry. Position function. Whoops. Okay, because my daughter was screaming. Okay, I was distracted right there. So I didn't use position. You might notice I used velocity accidentally. My bad. Okay, position t cubed plus 3t squared plus c, which is 2. Now I can plug in the 1. Okay, and that'll actually give me 1 plus 3 is 4 plus 2. Gives us our 6 right there. This way to do it is great without a calculator. Don't get me wrong. This method is superior because if it's something that's not integratable, you have to use this over here. So try to remember that fundamental theorem, okay? If they give you an initial condition and the rate at which a function changes, you can figure out that function evaluated at any value that you want, okay? So that problem right there, not so bad until suddenly you need to be able to do it without a calculator. So that's where the fundamental theorem comes in. Number 8 should be pretty good. F prime of pi over 9. Let's get F prime of x. A little chain rule action. In a world of derivatives, cosine is the bad guy. So negative sine 3x times 3. Maybe you're going right to negative 3 sine 3x, which is luscious right here. Okay, so I know that f prime of pi over 9 now. Okay, it's going to be negative 3 times the sine of 3 times pi over 9. Okay, and these will cancel out, divide by 3 top and bottom. And it's really negative 3 sine of, what is this, pi over 3? Remember, pi over 3 radians, always a 3 with a 6. It's really 60 degrees. So the sine of 60 degrees is radical 3 over 2. And yeah, you got to make sure you actually remember those trig values to get your negative 3 radical 3 over 2 here, which is our desired result, which is E. E! A lot of people are like, oh, I thought the sine of pi over 3 was 1/2, so I got negative 3/2. Bam, the AP squirrels got you. Some people remember that it's radical 3 over 2, but they forget to chain rule and multiply by the 3, and then their answer is C. So be careful. A lot of answers here, a lot of ways for you to actually end up getting these problems incorrect. Try to be careful, okay? So that was number 8 right there. Moving on to number 9. 9. All right, as far as number 9 is concerned, you might recognize this. You had it on your accumulation function, test right here. I think it was a quest. So we have the graph of the piecewise linear function shown in the figure above. Then they tell you that g of x equals the integral from -2 to x of f of t with respect to t. They want to know which of the following values is greatest. This right here, that's an accumulation function, okay? Remember an accumulation function? It's an integral with a constant lower bound, variable upper bound. You know, some people ignore the accumulation function here. They want to know which of the following values is greatest. They just plug in for each of these. They do g of -3. G of -3 would be the integral from -2 to -3 of f of t with respect to t. So that's the area between the function and the x-axis from -2 to -3. But be careful, your integral would be negative, right? Because you're integrating backward the regions above. So you can get all those areas that way. But it's a little bit better when you see the word greatest, because that implies that you're looking for a maximum. You know, and look, these values are all values of g, right? You're plugging into g. Function always represents y values. So you're looking for a maximum of g of x. Instead of just plugging in and calculating all the areas separately, worry about, you know, integrating forward regions above, positive, integrating forward regions below, negative integral. You could just figure out where g has a maximum. Surely, there must be some sort of test, okay? And there is the first derivative test, which means you want to take the derivative. Oh, take the derivative of an accumulation function. Do you remember? Okay, plug in the variable upper bound for the independent variable. Integral sign goes away, dt goes away. You just get f of x. So if you want to draw the g prime line, it's really the same thing as the f line. Are you telling me I want to draw the line for the graph that I'm given? That's what I check above and below. You can see 'tis bounded here from -3 to 2. Not that that really matters, because you can see that f is positive until you get to x equals 1. Then f is negative from 1 up to 2. And you can also see that f is equal to 0 at 1, which means g prime is equal to 0, which means the slope of g, the function we're trying to get this maximum of, is equal to 0. There's a horizontal tangent line. There's a max right there. See, the two endpoints, those are actually min. So I know the max value is actually going to be g of 1, okay? And that means I know the answer is D without having to calculate integrals whatsoever, okay? So it's a way to do that problem right there. You might not be in love with it, okay? But it's the easiest way to do it, and it's the quickest way to do it. You always want to think about speed on the advanced placement exam. Don't forget, okay? You know, moving on now to number 10. Okay, number 10, the graph of the function f is shown above. Which of the following has the least value? You know, you might remember that the integral right here, since you're integrating forward the regions above 1 to 3, it's going to give you the area between the function and the x-axis. It's actually going to give the exact area. But then they start talking about Riemann sum approximations, left, right, and mid. And they don't start talking about trapezoidal approximations until E, but they do eventually. You know, remember, we'll write it down. A lot of people don't memorize this. They just actually look at the graph. But if you think about your graph here, if a function is decreasing and you try to actually do a right Riemann sum, they didn't say how many intervals here. You could do as many as you want. It doesn't matter. The least amount, it'll be easier to see upper sums and lower sums. Right Riemann sum, plug in the rightmost value to determine the height of each rectangle. Okay, and you can see here, that would be a lower sum. So when a function is decreasing, that means a right sum will always be an under approximation. It's always going to be a lower sum, okay? And that means that when a function is increasing, the right sum will actually be an upper sum. It'll be an over approximation. Those reversed for a left sum, okay? If a function is decreasing, your left sum, that will now be an upper sum. When a function is increasing, your left sum will now be a lower sum. I don't think you need to memorize it, okay? I think you could just actually draw a graph and be like, okay, if I do a left sum right here, you know, what's going on? Use the leftmost x value, leftmost x value, leftmost x value, and you can see that's actually an upper sum right there if the function is decreasing. Trapezoidal sum, you don't care about increasing and decreasing, you care about concave up and concave down. So if f is honk up, you know, you see this one's concave down, but if f is concave up, the trapezoidal sum will actually be an upper sum. And if f is concave down, which this function is right here, then the trapezoidal sum will actually be a lower sum. I don't know if you can read that right there. If you want to know why, I'll draw it one more time. Trapezoidal sum, I'll only draw two trapezoids, trapezoid 1, trapezoid 2, because now you can see that if you draw and connect, you can see if it's concave down, you end up with a lower sum. If the function happened to be concave up, we could care less about increasing or decreasing. Trapezoidal sum, sometimes only a small amount of trapezoids make this easy to see. A lot, it's harder to see. Connect here. You can see we're actually getting an upper sum right there. So here, which of the following has the least value? So we're looking for, under approximations here, lower sums. The first answer, that's the exact value. It's probably not going to be the least value. Then they tell you left sum approximation. Remember, this function is decreasing, so a left sum will actually over approximate. So that's going to be over part A right there, so we're not interested in him. Part C, the right sum, is going to under approximate a good amount, right? So he's definitely in the running. Part D, a midpoint sum, it's always inconclusive. You can't tell by actually squaring this off and using the midpoint of each rectangle, whether it's an upper sum or a lower sum. The trapezoidal sum, we know this is concave down. We know it will under approximate it, but it's not going to under approximate it as much as the right sum. Okay, so which one has the least value? That's going to be C. Okay, the right Riemann sum with 4 subintervals of equal length. And that was number 10 right there. And that one's going to be C. So that one, you can memorize these right here or just kind of, think it out by, drawing it out a little bit. I think it's a better way to do it. Look at something like number 11. They give you the graph of a function right here. They want to know which represents the derivative of the graph of the function. So number 11 over here. That's where I wish I had a printer that, wasn't on the fritz. Hopefully, I'm going to be able to circumvent and take care of those things, or just buy a new printer eventually. Remember how to sketch a derivative? Okay, you just want to think about the slope of the tangent line to the graph. Slope of the tangent line is equal to 0 at this x value and equal to 0 at this x value. So the derivative will have a y value of 0. Think about your slope. Now go region to region. Slope is positive, less positive, less positive, less positive, less positive, 0. So plot y values that are positive, less positive, less positive, less positive, 0. Now you get the roller coaster. Slope is negative, more negative, more negative, more negative until right about there. Less negative, less negative, less negative, 0. All right, so plot y values that are negative, more negative, more negative, more negative until right about there. Inflection point. Less negative, less negative, less negative, 0. Then you can see the slope is positive, more positive, more positive, more positive. So it's going to look a little something like that. Which one of these does that look like? Looks like part B to me. Okay, so knowing how to sketch the derivative there, they're not actually asking you to sketch the derivative, but that knowledge of sketching the derivative should help you out for number 11 right there. Okay, moving on to number 12. Get back into more algebraics here. As far as number 12 is concerned, they give you e to the 2 over x power, and they just want to know what f prime of x is equal to. So remember, the derivative of e to the u times du over dx. So rewrite e to the u, multiply by the derivative of e's exponent. Remember, this is chain rule. The argument is not one single x. And by the way, 2 over x is 2 times x to the negative 1. Take the derivative, negative 2, x to the negative 2. So negative 2 over x squared, right? Same thing right there. Remember, if you differentiate a function, his argument is not one single x. You got to use the chain rule, okay? And this one right here, if you look at your answers, the only one with the x squared downstairs is D. Not that that means it's the right answer, right? There could be x to the negative 2's in the other answers. But you can see negative 2 over x squared times e to the 2 over x equivalent to this guy right here. So hopefully number 12 that was. Hopefully not too terrible. Moving on to number 13, more algebraics. Okay, they give you f of x is equal to x squared plus 2x. They want you to take the derivative with respect to x of f of ln x. Okay, so you need to get f of ln x first. Then you need to take the derivative with respect to x. A couple different ways to do it. You could get f of ln x first. I think many people would do it this way. Okay, so hopefully that's not too bad plugging in. Then when you take the derivative, okay, so I'll actually call this a new function. I'll call him g of x. Okay, because I get g prime of x. If you write f prime of ln x, technically that means you took f of x first, then plug ln x in. That's not the same thing. To take the derivative over here, this is chain rule. The outside function is x squared, okay? If you have a variable, it's not one single x raised to a constant exponent, that's a chain rule situation. Drop the 2 down like it's hot, rewrite the ln x, raise it to the first, multiply by the derivative of ln x, which is 1 over x. plus pull the 2 to the side, multiply by the derivative ln x, which is 1 over x. And here we get 2 ln x over x plus 2 over x. Does that look like stuff in our multiple choice? We can see we have common denominator here, so 2 ln x plus 2 quantity over x. It looks like that answer is there. It's actually answer choice A. Another way to do it is if you want, you could do it abstractly here, the derivative with respect to x of f of ln x. When you take the derivative here, this is an abstract chain rule situation, partially abstract. I don't know what the outside function is. I actually do, but that's if you do it this way. I know what the inside function is. The derivative of f of ln x, well, first take the derivative of f, the outside function, rewrite the inside function, then multiply by the derivative of the inside function. Remember chain rule, the derivative with respect to x of, pardon my language, f of u equal to f prime of u times du over dx, which is what we have right here. If you want to do it this way, now you got to get f prime of ln x, which means you got to get f prime of x. Not difficult, 2x plus 2. So f prime of ln x is 2 ln x plus 2. Then we'll multiply it by 1 over x, and you can see it's the same thing that we have written down here. So multiple ways to do these problems. It's taken me a long time to go through these problems. This is not just one day of work. Remember, it's multiple days. Okay, moving on to number 14. If you look at the success rate of number 14, it's rather low. People struggle with this. Polynomial function f has selected values of its second derivative given in the table above. So here we have a function represented tably. Which of the following statements must be true? Well, they talk about increasing, decreasing, and maximizing. And that's not the second derivative. That's the first derivative. Okay, so you can kind of wipe out a, b, and c right there. And then maybe you're like, I don't know how to do the next problem. I'm running short on time. I don't know how to do the rest of it. Just guess one, okay? You got yourself down to a great guessing situation. Believe it or not, there is a way for a second derivative to tell you whether or not you have a max or a min, but you also need information about the first derivative. We spoke about that earlier in the year. We'll talk about that, a little bit later on in review. But if you draw that f double prime line, be careful. People say it's bounded from 0 to 3. It's not. They told you f is a polynomial function, so it's not bounded here. That's the problem with given a function represented tably. They're not really giving you a lot of information. They tell you it's polynomial, which is nice. That means it's continuous and differentiable. But as far as which of the following statements must be true, that means if this statement must be true, that means the other statements, what am I looking for? If this statement must be true, I can take a sip of coffee. That means the other statements may be true. Okay, they don't necessarily have to be false. Okay, but they may be true, maybe not true. Here we want to know which of the following statements must be true. If you drew that normal f double prime line at x equals 1, you'd say that's a place where f double prime equals 0. And then you might be like, if I plug in a 0, I get a positive 5. And if I plug in a 2, I get a negative 7. So people say, oh, you got an inflection point right there at x equals 1. But if there is an inflection point at x equals 1, that means that the graph is going to change concavity somewhere from 0 to 2. 0 over here, 2 over here. So really, essentially, that would mean the same thing. If there's an inflection point at x equals 1, then the graph of f has to change concavity because f double prime changes sign. Does it have to be true right here? There's an inflection point at x equals 1. They didn't tell you that's the only place where the second derivative is equal to 0. So be careful. There could be another place, maybe at x equals 1/2, where the second derivative is actually equal to 0. Then maybe you plug in a 3/4 or something like that, and you get a negative second derivative. So that means 1 is actually not where the second derivative changed sign. It would change at 1/2 right there. The moral of the story is, I know the second derivative changes sign from somewhere from 0 to 2. I know that there is a place where f changes concavity because f double prime changes sign. I just don't necessarily know it occurs at x equals 1. So be careful. That's actually a pretty tricky question right there that people do struggle on. I wouldn't focus on that so much and freak out about it if you struggled on it. But hopefully a lot of people can get that. We did that one earlier in the year, by the way. Looking at something like number 15 here, it's actually a lot easier. If you want to integrate x over x squared minus 4 with respect to x, remember, if you want to integrate a quotient and the bottom is not being raised to a visible power, well, that means that, you could use the ln trick. Take the derivative of the bottom, we get 2x. It doesn't perfectly match the top, but think, can you multiply it by some constant to create the top? This is the derivative. And you can, 2x times 1/2 is going to be equal to x. So I'm going to put 1/2 ln absolute value of the denominator plus c. And we can see that answer is going to be there in part C here. And they still have absolute value right there. Sometimes they put a parenthesis instead if this quantity is always positive, but it's not always positive, okay? So 15, hopefully a lot easier. You're going to encounter things like 14. In the advanced placement exam, to get a 5, you only need about 68% of the exam correct. A lot of people are like, wow, that means the test is really easy. No, it means it's extremely difficult, okay? But these are things that we'll talk about. There'll be problems that you won't necessarily be able to handle, and even if you can, they're going to take you too much time. Your AP is going to be different, okay? Obviously, you have those 2 problems right there, only 2 free response problems. So you're a little bit different, but all the other years, there was always something that I said. Moving on to 16 over here. Okay, so as far as number 16 is concerned, pretty classic implicit differentiation situation right here. Whenever you see x's and y's frolicking about together, an implicit differentiation situation. How about this? They want the derivative with respect to x, but there are other variables present, okay? So let's actually take our derivative, take the derivative of both sides. The derivative sign is going to be cosine. But it's chain rule action here, okay? You know, take the derivative of the outside function, which is cosine, rewrite the inside function, which is xy, then multiply by the derivative of the inside function. Product rule. Backend, we know is y, times the derivative of the first, which is going to be 1, plus the first, which is x, times the derivative of the second, which is dy over dx. And technically, you need parentheses around this thing right here, equal to x. Now, as far as solving this thing over here, if you divide by cosine xy on both sides, you can. It actually becomes more annoying than you might think. If you distribute it, it's actually easier. You get y cosine of xy, okay, plus x cosine of xy dy over dx. I said it equals x, right? That was incorrect, okay? We want to take the derivative of both sides, so equals 1. My apologies for that right there. Solve for dy over dx, so x cosine xy dy over dx. I don't know if I made this problem easier or harder, is equal to 1 minus y cosine of xy. Okay, now divide both sides by x cosine of xy, and we get dy over dx is equal to 1 minus y cosine of xy divided by x cosine of xy. Maybe it actually did make the problem easier. It did. It looks like my answer right there is going to be part D. Okay, we'll actually take just a quick break right there, up to 42 minutes on this video. I don't know how long it's going to take to upload it to YouTube, so I'm just going to start another video exactly where this one leaves off. Okay, so we're going to stop right there, and I'll be back in the next video.